And the sensors will tell you, just like your car has a computer with sensors, oh, there's too much oxygen coming out in the emissions, we need to add more hydrogen. And so they have like really fancy chemistry, really fancy engineering. These are more complicated than nuclear power plants. It's a really big whoop. It takes geniuses to run this stuff. But coincidentally, you're making such a hot flame that you can still boil water to make electricity on the side. And the only emission is a small volume of ashes and a bunch of gases that are not dangerous if it is a high-tech incinerator. There's almost none of them. Japan has a couple, Denmark has a couple, and they're trying to build one in all places, Florida. Mm-hmm. If it works, we may start using more of these in the United States, and that's like the science fiction dream future for waste disposal. High-tech incineration, low-tech incineration. Okay.
Can you use the ash for some kind of fertilizer?
I think the ash you get is pretty hazardous. So it's a really good way to reduce the volume, but what's left is often really hazardous. So you technically get a smaller landfill volume, like 3% of the original volume. Mm-hmm. But what's there is usually more of a containment concern. As far as I know, you still get trash, just a lot less.
Yeah, so you keep the toxic amount and just reduce the size.
Yeah, exactly. You just kind of get rid of all the hydrocarbon ingredients. 49 is really interesting about e-waste. And like I said, 50 is also awesome about e-waste. 51 is awesome. 52 is awesome, all about e-waste. 53 is an example of these unregulated gold mines. Really interesting. I've told you before that a modern, legally compliant gold mine is a perfectly acceptable, modern, environmentally sensitive way to get gold. But an illegal, off-the-books, unpermitted, and unregulated gold mine is disastrous. You can read about it in number 3. 54 is just a neat idea. Somebody's trying to build bacteria that eats plastic as a way to get rid of pollution. You can imagine it would suck if that bacteria infected your computer, though. But we'll see. All right. There are a couple of study goals I'd like to discuss today.
Isn't that like one of the big topics that we get ideas?
Yeah, that's right. That's right. Yeah. Yeah, so they were right about half of that. Okay. I want to talk about e-waste, which is number 19. If you've done all your readings in the reader, then I think a lot of this will be repetitive, so I'm going to go quickly. I don't know about you, but in my experience, most of my electronics are really fragile and really hard to fix. How many of you have a cell phone that's been working for 4 years or longer? How many of you have dusted a cell phone in less than 12 months? You'll notice there were 2 kids who've managed to keep a cell phone alive for more than 48 months, but at least 8 people who've gone through a cell phone in less than 12 months. And by the way, I personally have dusted 4 cell phones in under a year. Yes? No, who's to say it's become useless for some reason? Here's the funny thing. It would cost an extra 75 or 80 cents to make your cell phone waterproof. But they don't want to. It would cost, who knows, a few bucks to make it easier to open your cell phone and replace the battery. But for a lot of your phones, they don't want you to. If you think about it, this this is a big change in our economy because if a part of your car breaks, we replace it. You don't have to throw away your car every 12 months. When you go home and the termites have eaten your door jamb, you can just install a new door jamb. Imagine if you had to just bulldoze the house and buy a new one. That's absurd. We all laugh at that. That don't make no sense. But why do we accept that with our electronics?
Computers are a lot more complex. Cell phones are sort of.
Some computers are modular. But let me remind you that even like tower computers have some modularity, but like motherboards expire after 2 years, and it's very hard to find an old motherboard that often can't communicate because their wattages have changed. I'm sorry, we'll ask you. We could make extremely modular computers. My dad and my brother, they just build their own towers, and whenever they're done, they scrap as much of it as possible to make their next tower. But the market doesn't do this. They're made to be garbage. My iPhone 4S has somewhere between 70 and 85 different metals and metal alloys. Not to mention glass, plastics, ceramics, insulators, and polymers. To recycle this, you'd have to be some sort of a crazy genius to separate this into the 300 or so separate components. And then figure out how to aggregate them to recycle. So we just don't. When you hear about the rise in electronics, let me remind you that it's not just America that has a lot of computers. And watch what happens when we talk about cell phones. They're much more successfully penetrating the rest of the world. There are even countries where the average per capita cell phone penetration is 2 cell phones per person. Japan in 2012 had twice as many working cell phones as humans. It's very strange.
Do they have a different social use for, like, why everyone?
I have no idea. Don't ask. Yeah, why is Alaska different from America? Maybe just no data. I don't know. Maybe the space is too big for cellular coverage. I don't know. Yeah, maybe there's no data. Could be no data. But the sad thing is, all those electronics got to go somewhere when they're washed up. And when you see those recycling days over at Earl Warren or whatever, just so you know, most of that recycling is not actually recycling in the way that you and I imagine. Like, what would it mean to recycle a cell phone? Give it to someone else. No, that's to reuse a cell phone.
Take the
Put it through the manufacturing plant backwards.
Right, demanufacture it. Take the useful parts, separate it out. Okay, use it for something else. Recycle. That's not how it works. Back in the day, all the stuff went to China. Then they got a lot of bad coverage. So for about a year, it was all going to Bangladesh. Then it got a lot of bad coverage. So for a couple of years, it was going to India and Pakistan. And most recently, we have shifted the electrical recycling to our very favorite Lipping Boy, Nigeria. When you think of recycling e-waste, I want you to think of it more as scavenging a landfill. I'm very curious. You see, this is an e-waste recycling facility. It's a landfill with a fence around it, and people pay to scavenge stuff out. Each of those televisions sells for about $1.50 to $2. These guys will go home, and one guy will smash all of the cases to get the magnet out of the back. because that type of monitor has a big old magnet in it. And that guy sells magnets to a scrap magnet buyer. Then he'll sell it to his neighbor for $1. And that guy will strip out all the wires, light them on fire, melt the plastic, and sell the leftover copper to a copper scrap collector. And then he'll sell it to his neighbor for 80 cents. That guy will take apart all the plastic, and he's got a giant plastic scrap pile that he'll drive over to the plastic recycling guy. And then he'll sell it to his neighbor for 50 cents. And that guy will take all the motherboards out, light them on fire, melt all the solder, and sell the melted solder to the lead and tin scrap guy. And he'll sell it to his neighbor for 25 cents, and I don't know what's left to get out of there, but maybe they can figure out how to get the little screws or whatever, and what's left is just open air dumping. E-waste recycling is not demanufacturing like we want it to be. It's scavenging, often in parts of the world that lack environmental and health protections. There have been tons of research papers about kids who do this, how it affects water quality, air quality, soil ecosystems, the food chain, neurological developments of children. You can see that guy is melting down wire in a cooking pot. Some guy went to one of these e-waste recycling centers in China, and people take the stuff home. They cook it in their home pots and pans, indoors, without safety equipment, and then they use those pots and pans to make dinner when they're done melting the motherboard or whatever. It is possible to do better. Ventura actually has a very green e-waste recycler. But we've got to be really careful about how we manage these materials. They're hazardous, they're toxic, and in many places, we're just outsourcing that environmental damage to people that have very little protection and access to medical care. So let's all go shopping. Okay. If we've talked enough about e-waste, we've got a bunch of good articles, like 4 or 5 really good articles on that. And the last thing for us to discuss today is integrated waste management and landfills. Integrated waste management is the entire system of managing our waste, ideally to reduce the volume of waste. Now remember, our current materials economy is not sustainable. It's a one-way street. We take stuff out of the ground, make it into products that we sell to people, they use it, and then we bury it back in the ground in a way that it can't be used. That is fundamentally unsustainable. I say, well, I'm done with my aluminum foil, I'll throw it in the garbage. And what I've done is I have extracted a limited resource, used it for a while, and then buried it with a bunch of hazardous waste in a place where nobody will ever be able to reuse it. It's stupid. In nature, this doesn't exist. You know, when the gazelle eats a leaf, it'll poop out material that will someday become a plant to become a leaf. In nature, all resources are fundamentally recycled. If not in the biological cycle, then in the geological cycle. But humans have found an exception to this. Our materials economy takes stuff out